Today's topic is compositions of transformations, and you can use the date of June 2nd. Your note packet should have 4 pages. You'll also want a ruler if you choose to do some graphing. So through this unit, we've studied 4 different types of transformations. We started with reflections, then we worked with translations, then we had dilations, and then most recently rotations. So when you complete a composition, what you're doing is combining 2 or more of those various transformation to form a new transformation, a final product at the end. The combining of 2 or more is just called a composition. It doesn't state how many transformations are there or what the order is. When you build a composition, we always start with the given vertices. We follow the instructions and perform the first transformation to produce our first prime. And then we continually build on the first prime, and then the double prime, and then the triple prime if necessary. So we never start over. We just build on whatever we've most recently completed. In this diagram, you can see we started with the triangle in red. We first reflected it in line M to create triangle ABC prime. And then we took that image and we reflected it in line N to create triangle ABC double prime. So this is a series of compositions. They're all reflections, but they result in a final image. One of the things that you'll notice through compositions is that sometimes, even though you go through a series of different transformations, when you look at the pre-image and then the final graphed image, sometimes you realize, hey, I could have gotten there in one simple step. And sometimes they'll ask you to identify what that step might have been. The order that you perform the transformation does matter. You will be provided instructions and you have to follow the specific order, or the final image we think you should get won't actually be the image that you do get. So we have a new notation to read. This open circle uses the word follows. So we have a reflection in the x-axis follows a translation of 3 to the right, 4 up. Because the R or the reflection follows the translation, it actually comes second. So in this type of notation, we're going to start on the right and read backward. So we're going to do the translation first and the reflection second. Like I said earlier, sometimes going through a series of transformations, when you look at the pre-image and then that final image, you could rename it as one single transformation. The unfortunate thing is you don't know what that single transformation is until you've done all the work. In this picture on the left, we start with the blue triangle. It appears as though it was reflected over the y-axis based on the rule I see, and then it was reflected in the x-axis. Well, when you look at the blue and how it relates to the green, instead of performing all those steps, it appears as though we could have rotated this 180 degrees and got there in one step. This would also be a reflection through the origin. In our second diagram, we reflected it over the first line and then again over a second line. But when you look at the orientation of the figure, from blue to green, I simply could have just slid it over. So it would have been a translation that would have gotten me there in one simple step. In example number 1, we're given 3 points. It says the use of the grid is optional. If you know your rules well, then I would advise just do a mapping. You don't necessarily have to graph. So I'm going to begin by listing my 3 original ordered pairs. And then I'm going to start with the translation. Remember, the rotation follows the translation, so we're working backward. So translation rules are adding and subtracting. We're going to add 0 to the x value, and we're going to subtract 4 from the y value. So a prime, 1 plus 0 and 2 minus 4. We'll use the same rule for b prime and c prime. Now, with the composition, we're going to build off our first prime, and now we're going to rotate 180 degrees. So there's my rule. Rotation of 180 simply says to negate the x and negate the y. So for a double prime, we have -1 and now +2. And we'll use that same rule on B prime and C prime. And we've produced all the double primes, and we have our final example. Without graphing this, it's difficult to tell how we could have gone from ABC to the double primes in one simple step. In example number 2, we have these 3 ordered pairs. Again, the grid is optional. In your notes, this is the notation that's being used. I'm going to ask you to change this reflection of y equals x in a second. We're going to change it to an axis. When it's set up like this, you're going to perform the transformation on triangle ABC, and we're going to work our way out. So we would first reflect, and then we would take that result, and then we would dilate. I'm going to ask you to write it in a more familiar notation, and I'm going to ask you to change the reflection to the y-axis. So you can rewrite this and change it to reflection in the y-axis, and then a dilation with a scale factor of 2. So we begin all mappings that don't use the coordinate grid with our 3 original points. I'm going to first reflect in the y-axis. We're reading this from right to left. When you reflect in the y-axis, the x value changes, the y value stays the same. So A prime, B prime, and C prime. Now we're going to build off our primes, so we're going to dilate these points by a scale factor of 2 and make the triangle twice its size. Because it doesn't state otherwise, the rule shows me that we're dilating with a center of dilation at the origin, so we're going to apply our multiplication rule. We're going to multiply 2 times 3 and 2 times 0. So A double prime is at 6, 0. We'll multiply for B double prime and C double prime. And again, without graphing, I don't know how I could have gotten there in one step. In example 3, I do not have a grid. I tend to not use these. Again, if you know your rules well, you can just start with the 3 ordered pairs, so that's what I'm going to do. We're going to dilate by a scale factor of 1/2, then we'll reflect in the x, and then we will translate. So we're going to multiply 2 by 1/2, and then the y value of 2 by 1/2 as well. We'll do this for B to get B prime, and C to get C prime. Now we're going to reflect in the x-axis. When you apply this rule, the x value stays the same, the y value is negated. So double prime, x stays the same, y changes. We'll do the same for B prime and C prime. C prime, though, does become an invariant point from C prime to C double prime. I did apply the rule, its location didn't change. And finally, building onto the double prime is a translation. We're going to add 2 to x. We're going to subtract 5 from y. So A triple prime, 1 plus 2 is 3. -1 minus 5 is -6. We're going to use the same rule for B triple and C triple. Our last example, we'll see some of this on our day 2 work, but you won't see this today. In some cases, what they'll do is provide you an image. Here we're provided trapezoid ABCD, and then its double prime image. They want us to describe a sequence of transformations that maps the original trapezoid to the double prime. There's different ways to do it. The order can be changed as long as it ends up in the double prime location. So the first thing that I notice is the original image is in quadrants 1 and 2. I notice A and B are the base, but when I compare it to the double prime, A and B are not in the same location. So the first thing I want to do is take my original trapezoid and I want to reflect it in the y-axis to flip it over so the letters will be on different sides. And you'll notice right here. So if I flip it over, A will now become B's location. So that puts us in a better spot. Once I reflect it over the y-axis, I'm actually going to slide it down so that side AB and side A prime B prime are located in the exact same spot. So I'm going to translate the trapezoid down 6 units. I'm not moving left or right. So if you were writing a rule, it would be 0 and then -6. Once the two trapezoids are kind of base to base, what I want to do is flip it down. So I want to flip it over the base AB or A prime B prime. So that location right here is a horizontal line at y equals -4. So I'm going to finally reflect my trapezoid over the line y equals -4, and I will finally place it where the double prime image is located. Instead of writing it in words, you could use the new notation that we learned today with the circle. So this would be the proper order: reflect in the y, then translate down 6 units, and then reflect in the line y equals -4. You won't see any examples on your homework tonight that are like this, but it's just worthwhile to mention the different steps that it takes to go from the pre-image to the final image. Tonight's homework is number 130. It's a two-sided sheet. There are no grids. Please make sure you show a full mapping. So you're going to write the originals, you're going to place the rule with the arrows, and then you're going to keep building your first prime, your second prime, your third prime. In addition, tomorrow there won't be any notes, but we are going to continue compositions for one more day. This is part 2. I'll send you a separate email. This will be homework 131. This one is very similar to the one you're going to complete today at 1:30. You're going to go ahead and complete the transformation, the full composition. You have to do a full mapping. You can do it here in the white space. You can even turn the paper sideways and write it the long way. Make sure you follow the directions, make sure you show a complete mapping, and then at the end, it's asking you to see if you can come up with a single rule that took our pre-image to our final location, and don't forget to record that as well. If you have any questions as you go through this assignment or the one that's following, please make sure you get in contact with me. Otherwise, have a great day.